In this video, we are going to show you how different indices help you analyze your crop. But first, let's take a step back and talk about light. Visible light makes up only a small part of the electromagnetic spectrum. Plants absorb visible light to grow, and they reflect near-infrared, or NIR, light, which we are not able to see through the naked eye. By analyzing past the visible spectrum, we are able to better evaluate plant growth. As you can see, healthy plants reflect mostly NIR and green light, while stressed or dead leaves will reflect more red light. NDVI is one of the indices we use. It is calculated by using red visible light and NIR. Red light is mostly absorbed by the top of the plant canopy. The NDVI index reaches high values when the field is covered by healthy reflecting leaves, which makes it a good indicator for plant health and biomass density. However, NDVI tends to miss subtle vegetation changes in fields with high biomass density. So now we're going to use the compare tool of the fluorescence platform to analyze NDVI against MSAVI in a cotton field 2 months after sowing. MSAVI was developed to minimize soil influences on canopy spectra by incorporating a variable soil adjustment to NDVI. Basically, MSAVI tries to minimize soil reflectance and maximize any changes in canopy reflectance. MSAVI tends to have higher values than NDVI, as it is only considering the parts of the field that contain canopy. Thus, MSAVI will be more sensitive during early crop stages, allowing you to follow your crops during the first months after sowing. This is an image from the same day, but measured in the NDRE index. While NDVI calculates using all red light, NDRE uses red edge. Red edge is the red that is at the very end of the visible red color. This type of band penetrates better through the canopy and would give us an idea of the canopy structure. This index complements NDVI as it's sensitive even with high crop biomass. As you can see here, we are comparing NDVI with NDRE by using the Compare tab. NDRE shows low values for that particular date, as the crop is not well developed yet, while NDVI values are higher. If we analyze the crop 2 weeks later, MSAVI is almost saturated, represented in the blue color, whilst NDVI is not yet reaching the highest reflectance values. If we switch MSAVI to NDRE, we see NDRE is less saturated than NDVI. For this reason, we mostly use NDRE when the crop is fully grown. Taking into account the sensitivity of the different indices, we would implement the most sensitive, MSAVI, at early stages, NDVI at middle stages, and NDRE at late stages of growth. As the crop transitions to senescence, it would be useful to return to more sensitive indices like MSAVI, as the foliage would decrease. CCCI is another one of our main indices. We've found strong correlations between CCCI and nitrogen content from tissue samples. Nitrogen is a key component of chlorophyll, which is the main pigment involved in photosynthetic activity. Photosynthetic activity is also a good indicator of plant health, and hence why we use CCCI. By correlating CCCI with the tissue samples, we are able to estimate the nitrogen variation of the field, generating Nmaps. These Nmaps provide the ground truth and will help you precisely fertilize. TCI stands for True Color Imagery. This tool allows you to see a crop without any kind of analysis. If we compare the TCI image with the NDVI, we should be able to see a correlation between the both of them. Check the right-hand side of the compare bar to see how your field actually looks and how that image correlates with the NDVI imagery. There is also a color scale, which allows you to check the NDVI values for each color. So that wraps up our tutorial on indices, and I hope that you've learned how and when to use different indices.